Hi and welcome to this video on expected value. So this video is going to cover expected value, what it is and how we calculate it. So expected value is part of the probability section of the course, but there is a very strong link here to statistics. So we got an idea to make sure that you've covered or have already revised basic statistics. So things that you would have had at junior cert, mean, median and mode, etc. So in the video we're going to cover what does expected value mean, calculating expected value of a game and using the expected value for decision making. So that's going to link to some of our exam questions. So what is expected value? Well, expected value is the value you expect to get from an event. So for example, when you roll a fair six-sided die, the expected value is 3.5. Now, when I make this statement, this usually is where students go, what? That doesn't make any sense. How is it possible we're not able to roll a 3.5? So this is absolutely rubbish. I get questions all the time about why does this work? So what I would say is, well, if I call this mean instead of expected value and said the mean value on the die, would that make more sense for my answer? And the answer would be yes. So if we added all of our numbers on my dice together and divided by 6, would I get 3.5? And yeah, that's exactly what we get. So 1 plus 2 plus 3 plus 4 plus 5 plus 6. Divide that by 6 and you get 3.5. So what we're actually talking about is the mean. I have or average, but we all know specifically I'm talking about the mean. So it's the mean value. So expected value is the probability term for mean or average that we use in statistics. So I suppose, well, why don't we just call it the mean? Well, the use of expected value is a little bit different. Yes, effectively what we're doing is calculating a mean. However, the use of it is very different, and we'll see that as we work through. So when I do the expected value, it's the value we would expect to get on average if we repeated an experiment a large number of times. So basically, if I rolled my dice, if I spent the day rolling my dice and I got thousands of rolls, the average of all those results would hopefully lead to about 3.5, or that's what we would expect. Okay. So a die is easy because all the numbers have an equal chance of occurring. Okay, so we have an equally likely chance of each number appearing. So what would happen in a different scenario? So I have a little clock or a little counter here, and it has 3 sections. It has the 8, a 4, and a 12. So it's a spinner. I spin this, and I have 3 possible outcomes. So what is the expected value when this spinner is spun? Well, if I added 8 plus 4 is 12 plus 12 is 24, divide that by 3, I get an answer of 8. So I would say the expected value of spinning the spinner is 8. But is that the correct answer? And hopefully you are saying no, because it's not the correct answer. And there is one huge issue that we have with this particular spinner. And that issue should be very clear, and it is that they are not equally likely, i.e. the 12 sector here has a much better chance of occurring because it is much bigger than the other 2. So expected value of 8, well no, like I said, because the 12 sector is bigger, it wouldn't be fair to count it the same. So what I could do is I could actually divide this into 2 pieces. I'm going to do a bit of writing now. So I divide that and say, well, this is a 12 and this is a 12. So now I actually have 4 sections. I would add 8 and 4 is 12, plus 12, plus 12, that would give me 36. I divide by 4 and it gives us an expected value of 9. So expected value of 8, we're going to be big, no, but expected value of 9, yeah, well, I should, sticking to our colors, I should do that in a nice green tick. Yeah, so expected value of 9, much better. So it's really important that we're dealing with equally likely events because, and I'll give the example of, if I told you you have a 10-minute class test and you have a 2-hour summer exam, and for your final grade I'm going to add the 2 scores together and divide by 2. That wouldn't be fair because obviously the 10-minute test doesn't represent the same as the 2-hour test. So what we will talk about that is they're not equally weighted. And this is the same idea we have here. It has to be fair, okay? So what we could do instead, because we do get a lot of questions like this, so it's more likely we're going to get a question where they're not equally likely. So the exam questions we see especially, things are not always going to have the same chance of happening. So we're going to look at an easier way to deal with this question. And that is using the probability of the outcomes to help us. So what I mean by that is the probability of getting an 8 is a 1 in 4 chance. Because technically this is 2 sections. Plus I have a 1 in 4 chance of getting a 4. And I have a 1 in 2 chance of getting a 12. Now, if you want, I can write that as an 8 over 4 plus 4 over 4 plus 12 over 2. Now, I know that this can go into the calculator, but I'm trying to demonstrate something. And if I put this all over 4, I get 8 plus 4 plus, now I've had to double that, 24. So effectively, using the probabilities, hopefully you can see now, is the exact same as what we did with regards getting a mean. The difference between using the probabilities and just adding the numbers together and dividing it is when we add our numbers together and divide, there's an assumption that all are equally likely to happen. Now, in a statistical sense, that is what happens, and that's why we call it mean. For an expected value, we can't necessarily say that all our outcomes are equally likely. So we're going to have to take this probabilistic approach instead. So that gives us our 9. Exact same answer as we got the last way. So this leads us to a formula for expected value, which is different to that of our mean of adding and dividing, and it's this formula here. Now, some notes. This is not in your log tables. You need to learn it off by heart. So, EX, okay, so this is the expected value of X. Okay, expected value of X. And X is a given outcome. This is capital sigma or summation. So this is sum or add. So we're going to add together X, the outcome, times the probability of X happening. Okay, XPX is the probability. So there's multiplication there. Probability of X happening. Okay. So that is our formula for expected value. We multiply the outcome times the probability of it happening, and we add them together. It's exactly what I did on the previous page, okay? But we do have a specific formula for it. So the expected value will help you to figure out if a game is fair or if you will win or lose money in the long run. So this is where we can talk a little bit about gambling. And if we think about just a casino game, so a very basic casino game where you spin a wheel, and wherever the counter, the ball lands, you win that amount of money. Now, what I would say is sometimes we don't really think about these casino games, but there is somebody who has worked out, well, how much on average are we going to have to pay out? So how much on average do people win? And the smart thing to do from a casino's point of view will be to charge more than that so they always make a profit. So if you ever heard the phrase the house always wins, that is what they're talking about. So having a better understanding of expected value will hopefully give you a much better understanding of gambling and will hopefully lead you to understand that you will never win when you gamble. So you're better to stay away from it. If you won, or if people in general won at these games, then casinos wouldn't exist because they would go bust. So bear that in mind. They love to bring in exam questions talking about this because it's a very interesting topic. So they're very real life situations and we'll see them. So let's take a very basic example to start. So the circle here is divided into 6 equal sectors, and that's important. So each one has a 1 in 6 chance. You pay €10 to spin the arrow and you win the amount in the sector when the arrow stops. What is the expected amount you win or lose in this game? Okay, so I will always approach these in the exact same way. I will approach this as looking at the winning, because that's how majority people work. They think about what they win, and then we'll think about, well, how much did it cost me to win that much? Okay, so first thing I'm going to do, I'm going to do my EXP of X. Okay, so that's my expected value is equal to that. So what I'm going to do is I'm going to figure out, okay, give me one of my outcomes. So that's €10. And the chance of that happening, I have 2 in 6 chance because there's 2 sectors. Plus €30, I have a 1 in 6 chance of that happening. Winning nothing, I have a 2 in 6 chance of that happening. And winning €5, I have a 1 in 6 chance of that happening. Okay, so I've multiplied my X, which is my outcome, times the probability of that outcome, and now I'm adding them together. So you can put that all into your calculator and we should get 55/6, but I'm dealing with money, so we're going to go down to 2 decimal places and we get 9.16. Be careful, it's a recurring decimal. So what that means for us is 9.17. So remember, press S to D again if you're using a Casio to show that full thing, and you'll see that it's 9.16666666, so we can update it. So what this is telling us is the expected amount that we would expect to win is 917. So, excuse me, when we play this game, we will on average win 917. Now, I pay €10 to play, so I will not make any money. That is for sure, okay? So this is how much I win. So I pay €10, and on average, I win 917. Therefore, I lose each time I play. It mightn't seem like a lot, but 83 cents. Okay, so that's overall. So if you can imagine, effectively what's happened, when somebody plays the game, they're literally handing the person who owns the game 83 cents. 100 people, that's €8.30. 1,000 people, that's €83. And it all starts to build up. So if you could understand the expected value and say, well, actually, I wouldn't play this game because there's no way I'm going to win at it, you have a very good understanding of maths. However, saying that, you'll always have the person who'll say, but what happens if you pay down €10 and you win your €30 and you've won 20? And that happens. Of course that happens. And you'll have people who will lose a lot more than 83 cents per play. But this is a mathematical prediction on what's going to happen. So it's not perfect, but it gives us a very good idea of what's going on. So now let's look at an expected value exam question. So I will do a little bit of permutations, combinations here to start, and then we'll work through the expected value piece. So 2 different games of chance are shown below and can be played at a charity fundraiser. Okay, so maybe in this case, if they were taking our 83 cents, we wouldn't mind as much because it's for charity. So maybe in that case, gambling's okay. So in each game, the player spins an arrow on the wheel and wins the amount shown on the sector that the arrow stops in. Each game is fair in that the arrows are just as likely to stop in one sector as in any other sector on the wheel. So it's equally likely in the terms of the sector. However, you can see that sometimes numbers are repeated, and that's what means that's what has led this idea of some outcomes are not equally likely. So John played game A 4 times and tells us he won a total of €8. How many different ways could he have done that? Okay. So John here won €8, so there's only a few different ways he could have done that. And to do that, he must have got a 0, a 0, a 5, and a 3 in some kind of order. Now, and that's what they're basically asking us, how many ways can this be done? The thing about it is, because we have a 0, 0, it complicates things. So usually we would say, well, how many ways can this be arranged? So this arrangement will be permutations. So we would usually say, well, there's 4 that could go in there, 3 options here, 2 options here, 1 option here, multiplying that out, and we have 24. However, the question I would then ask is, well, if he tells you he won 0, 0, 5, and 3, but then he swaps the zeros and tells you, well, actually, another way could be 0, 0, 5, and 3. Are these actually 2 different ways? So the answer is no, they're not, because they look identical. There's no way to distinguish them. So because those zeros could be interchanged, we're going to do something we would have seen when we did permutations and worked with the idea of maybe vowels going together. So treating them as one thing, but then having to multiply by how many ways they can be arranged. So one way to think of this is, well, every time we swap the zeros, we've created 2 different permutations that aren't really different. So to get the correct answer, we're dividing by 2. And that will give me 12. So there's 12 ways that this could be done. Really what we're talking about is the idea to arrange 0 and 0. There are 2 factorial ways to do that. So that 2 there is actually coming from the idea of 2 factorial, but you can also think of it in a logical point, from a logical way of saying, well, here's 1 option, here's 2 options, but really they're the same. So there's only half of the options I think there are. So the second part of this question says to spin either arrow once, the player pays €3. Which game of chance would you expect to be more successful in raising funds for the charity? Okay, so we have to kind of step out of our heads as a player. We are now coming from a charity point of view. So we need to figure out, well, where are we going to make the biggest profit? So what we're going to work out is for game A, we're going to work out its expected value. Okay, so expected value is going to be the sum of x times the probability of x. Okay, so to work that, I have 5, which has a 1 in 5 chance of coming up, plus 0, which has a 2 in 5 chance of coming up, plus 6, which has a 1 in 5 chance of coming up, plus 3, which has a 1 in 5 chance of coming up. So into their calculator that goes, and we get €2. So that's the payout. And they will raise with that one €1. Okay, that's pretty good. So every time somebody plays this, the charity gets €1. So like I said, only time gambling is good for the charity. So let's take a look and do the same thing for game B. Okay, so I have €5, which now is a 1 in 6 chance of happening, plus 0, which is a 1 in 6, plus 3, which is a 1 in 6, plus 1, 1 in 6, plus 2, which has a 1 in 6 chance of happening, plus 4, which has a 1 in 6 chance of happening. And into the calculator. And that gives us a $250 payout. Okay. So they will raise with game B. Every time somebody plays, they pay €3, so they're going to raise 50 cents. Still good. As a player, would you play either of them? Well, neither are fair. However, from the charity's point of view, game A will do much better. So let's look at another exam question example. And again, I've left in most of this question, so just so we can work through it. So a local sports club is planning to run a weekly lotto. To win the jackpot of 1,000, contestants must match 1 letter chosen from the 26 letters in the alphabet and 2 numbers chosen in the correct order from the numbers 0 to 9. In this lotto, repetition of numbers is allowed. So the idea, or the example of M33 is allowed. calculate the probability that M33 will be the winning outcome in a particular week. So the chance of it being M is 1 in 26. The chance of it being 3 is 1 in 10. Now, big mistake students tend to make. 0 to 9, so starting at the digit 0, if you need to count your fingers, do. And there are 10 digits. So although we start at 0 all the way up and we end at 9, that is 10 digits. So 1 in 10 chance of that happening, and a 1 in 10 chance of getting a 3 again. So we get a 1 in 2600. So that's the probability M33 is the winning outcome. But that is also the chance of winning. So you have a 1 in 2600 chance of winning. Okay. So if a contestant matches the letter only or the letter and one number, but not both numbers, they'll win €50. Using the table below or otherwise, find out how much the club should expect to make or lose, correct to the nearest cent if they charge €2 per play. So let's fill in this table. So they've kind of broken it down. So just to remind you, the expected value is given as the sum of x times the probability of x. And they've actually given us x, px, and then they've told us to multiply them together. And what we're going to do is we're going to then add them. So if I win the jackpot, I win €1,000. If I match the letter and the first number, I win €50. If I match a letter and the second number, I win €50. And if I match the letter and neither number, it's 50. Okay, so the letter is just 50. And if I fail to win, I'll win nothing. Okay, I'm going to deal with that €2 at the end. You could put this in, but it overcomplicates the question. So we're going to work this out and then work with the €2. So that's the chance of winning the jackpot. Well, actually, you've just worked that out above. 1 over 2,600. So what's the chance of matching the letter and the first number? Okay, so I'm going to do a little bit of work over here. So I match my letter, I match the first number, but then I don't match the second number, and that's important. So this gives me 9 over 2,600. I get a similar answer here when I don't match the first number, but I do match the second number, and I get 9 over 2,600. So here I get the letter, and I don't match either number. So that gives me 81 over 2,600. And now there are two ways that you can figure out I failed to win. This is an example of an exhaustive event. So these will all add up to 1. So I can add the probabilities I already know and take it away from 1. Or I could also maybe have figured out at this point the only way I don't win is if I mess up on the letter. So it's the letter is key. So really, I just don't want to match the letter. After that, I don't care. So not matching a letter is 25 over 26. So what I'm going to work out now is multiplying x times the probability of x happening. Now, I'm going to keep this in its simplest form if I can. So 1,000 by 2,600, so that gives me 5 over 13. So 50 times 9 over 2,600, that gives me 9 over 52. I get the exact same answer here. And 50 times 81 divided by 2,600, that gives us 81 over 52, and then this gives us 0. Okay, so although we need that probability, we were going to get our 0 here anyway. Back to my formula. I've done the x times the probability, so now I'm going to add them together. Okay, so I'm going to add 5 over 13 plus 9 over 52 plus 9 over 52 plus 81 over 52. And that will give me 119 over 52 and be careful it is recurring. So basically that is 2.288, which is 2.29. Okay. So that is how much we would expect to pay out on average, and they're going to charge €2 per play. So therefore, they will lose. This is the club now, 29 cents per play, because they're only charging €2. So now, if you were looking at that lotto, that's a lotto you should play, because you would on average win. However, it's not good for a fundraiser because they're losing money each time they go. So we're going to work with this as we move into the next part. So the club estimates that that the average number of players per week will be 845. They want to make a profit of 600 per week. They're definitely not doing that now because they're making a loss. So there's two ways to work this. The simpler is bringing everything down per play. So they want to make €600, and they have 845 players. So if we divide our 600 by the number of players we have, we will get roughly, they want to make 71 cent profit per play. They currently pay out, so from our previous question, $2.29 per play. So that's what they pay out on average. So if they pay that out, so they pay out $2.29. They want to make a 71 cent profit per play. So that's my profit per play. So then they should charge $2.29 that they pay out. So they should definitely cover that. Plus they should charge the profit that they want to make, which gives us €3, and that's how much they should charge per play. Now, you could bring that $2.29 back up to the total amount by multiplying by 845, but they do want us to charge, they want us the charge per play, so we're going to have to divide it down anyway. So this is the easiest way to work that.